Grade 12 applied. Lesson 4, exponential functions. So here's the basic form of an exponential function, y equals a, b, and if you look, the exponent's way up here, the x value is up here. And there's a couple things you can tell about this. If a is greater than 0, which means positive, and b is greater than 1, then you have an increasing one. So something like this. See how it's increasing. If a is greater than 0, again, if a is positive, but b is between 0 and 1, so it's like a fraction or a decimal, then it's a decreasing one. So if you look down here, you can see this is a decreasing one. Now, if you want to see what these look like putting in the TI-83, it's really quite simple. So what we can do is you go into y equals, and you can put in the function. So 2 times 3, and if you want to raise it to the power, you see the little hat here? Put that up there, and you can raise it to, and hit this little button here with all these weird symbols on here, and that'll put the value x in there. So that'll allow us to put the equation in. Now, we got to set the windows. And we haven't done a lot of setting the windows. So let's set the windows manually, just so you know how to do it. So what we do is we can go to Window. And what this does, it pulls up the x min and the x max. So the x min is all the going to the negative. The x max would be going to the positive, like in positive infinity. And then y max and y min. Now, when you put this in, be careful that you put the negative in and not a subtract symbol. So for instance, if I put in subtract 10, it's going to give me an error. So you have to be very careful and make sure you put in the negative, which is right beside the enter button there. And it's smaller. You can see it's negative 10. So set your windows to negative 10 to positive 10. Don't worry about the scale here, the y scale and the x scale. Those are always just usually set to 1. Y min, then negative 10, and y max. Now, if we hit graph, what that does is it gives us a basic window, negative 10 to positive 10, negative 10 to positive 10. And then there it is. And if you look, that looks really similar to the graph we have there. The only difference is the window settings. You could have got rid of some of the y min down here if you wanted to. So you can see that function there. So that's an increasing function. Okay, and it tells us a couple things. The y-intercept is 2. You can see that. Oh, that's kind of interesting there. Make sure you remember that. So let's look at the next one down here. Y equals 4 in brackets 0.7. So this is decreasing because that's less than 1 and greater than 0. And you can see that. And y-intercept is 4. Oh, that might have something to do with it. Okay. So flip to the next page here, and we'll look at 4 different ones. We'll set up a little table here based on that. So what we do is we have exponential functions. So you can look right away. You can see here, that's a 5. That's going to be increasing. 0.3, that's going to be decreasing. 1/5 decreasing, and 1.7 increasing. So that's that first table here. There's no x-intercepts because they're all above the x-axis. What's the value of the y-intercept? Well, it's easy. What's out the front here? 3, so that's a 3. What's out the front here? 4, that's a 4. A 2, a 2, and a 3.5, and a 3.5. End behavior, these all go from quadrant 2 to 1. The domain is all the same. It's all real numbers, so that means all the negatives and all the positives. And the range is everything above 0. It doesn't include 0 because there's no x-intercepts in this case. Okay, now what we can do is we can actually do regression on this one also. So what we have is we have L1, which is time, and the temp of hot water. So as it sits over time, it cools down. Okay, so let's grab our calculator, get rid of this graph here. We can go to y equal, we can make sure we get rid of that equation. We don't want that in there. We want to put all this information under stat. So go to stat, go to edit, and you're going to put this as L1 and L2. So pause the video, and you can put that information in, and then you can get back to going this. Okay, so L1 and L2, all the information's in there. We want to plot this. Can't remember how to do that. Oh yeah, you got to turn stat plot on. It's probably already on still for you, but I'm just going over to make sure you remember. So we go to stat plot, we hit enter, turn it on. Yeah, there it is, perfect. So now it's on. And how do we do it? Remember, you go to zoom and zoom stat, because then it sets the window for you. Zoom stat, hit enter. There it is. Oh, there's the data there. Oh, you can see it's going down. Okay. So how do we find the equation? Okay, well, that's not that difficult. Stat, calc, and we're doing an exponential regression here. Okay, so stat, calc, exponential regression. Keep going down the list. There it is there, EXP, right? Hit enter. It's going to do L1 and L2 automatically if you hit enter. If not, you can put them in. And there it is there. So we can put it in that form. A times B raised to the power x, right? Now, if you look, oh, yeah, that's less than 1. That's why it's decreasing, right? Remember, if it was greater than 1, it'd be increasing. Now, we have the equation there, and we can see all the, I just went to 4 decimal places. We have the equation there. We need to put it in the graph. Do you remember how to do that? Well, okay. go back to y equals. Remember, you don't want to type in all these numbers because that's a waste. So we go to y equals. It's all stored under stat. Oh, sorry. That's my mistake. Quit that one. It's not stored under stat. Go to y equals again. It's under vars. See, even I make the mistakes there too. So go under vars. Go to statistics. Go over to EQ. There it is, the regression equation. Stored it in memory. You can plug it in. There it is. Beautiful. So when we hit graph, now it's going to draw the line of best fit for those points. Yeah, there it is. Takes a little bit longer because it's curving down. The exponential always takes longer. Okay, so that's what it should look like on your TI-83. Okay, so let's go to the next question here. So estimate the temperature of water 15 minutes after the experiment began. Okay, so what we can do is this second calc one, we can put in the x value. So we go, right, and you can look at all the instructions are on your sheet there. So go to second calc, hit value, hit x equals 15, hit enter, and that should give us a value of 52.2984 degrees, right? Nice and easy. Interpolation because it's within the graph. Okay. Next part says estimate the time when the water temperature reaches 30 degrees Celsius. Okay, so it should be on the graph here. So let's try it again. So we're going to graph y equals 30. Remember, this is where we throw in the horizontal line. So y equals, go down here. We are putting in, sorry, what number? We're putting in 30. Okay. Hit graph. There's our horizontal line, and we want to find that point right there where it intersects. To do that, second calc, down to intersect, first curve, second curve, guess. Remember, it's always the guess. Make sure you always look at the next one. So at 30 degrees Celsius should be approximately 34.6772 minutes later, right? Okay, now all these regression ones are the same. Again, put the data in, graph it, do the regression, throw the equation in, and then use that to answer a bunch of questions.